As you can see before you is a bunch of single board computers. They range from the popular Raspberry Pis to lesser known Orange Pis to Banana Pis to Odroids. Odroids are out of South Korea, whereas your Orange Pi and Banana Pi are based out of China, and the Raspberry Pi is based out of the UK, but mostly manufactured in China. So we're going to get started with the hardware review today of all of these boards. We're not going to do a software review, that's going to be a later part, and we're not going to do a performance review, that's also going to be in a later part. So let's get started with the smallest member of our team. We're going to go over the Raspberry Pi boards first. Here you have the Raspberry Pi Zero with its SD card slot, HDMI port. This is a mini HDMI port, which is a pain in the balls. And you have two ports. One is a USB Otg port and the other one is the power port. So we've actually tested this. This port can forward over 2 amps from this to here. And if you put a passive Otg hub here with like a bunch of devices, as long as your power supply is sufficient, this should be able to handle the current. So this is based on the ARMv6 instruction set, so it's a little older of instruction set than the rest of these boards except for the B Plus here. It's a single core and it's operating at 1 gigahertz with 512 megabytes of RAM in a POP package. So if you look at here, you can see the memory sitting on top of the this SoC itself, the BCM2835. So this is a relatively slow board. It's going to be about 10 times slower than anything else here. And you know, it's good for, it's $5, but it's basically vaporware at this point because nobody really can buy it in quantity. The next board we're going to go over is the Raspberry Pi B Plus. So this came out a while ago in 2014. And this board has the same processor as this, along with the same POP package of 512 megabytes of RAM. Being a full-size board, this has the USB, micro USB power, full-size HDMI, a audio / composite port, and a full-size Ethernet and 4 USB ports. So these are USB 2.0 ports, and they're shared in bandwidth. So these don't have unique root complexes, so the 480 megabits is entirely shared across all of these ports. You have the DSI interface, this is the DSI interface and the CSI interface for MIPI standard, which means you can plug in like the 5 megapixel camera into this board, and the onboard GPU encoder. It's actually not the GPU encoder, it's a separate like logic within the video core that does the encoding. And it's able to convert the camera input directly into H.264. So there you have this, and then this is a standard 40-pin GPIO. Since this is the B Plus model, it's compared to the prior B models, it has one more GPIO ports. Before it was 40-pin, now it's, before it was 26-pin, now it's 40-pin. And then the newer boards by Raspberry Pi all share this layout. And then they made a standard called the HAT standard based on this for compatible accessories. So we're not going to get to the individual GPIO pins and what they do and the special functions of each. So the next board is the Raspberry Pi 2. So this is when Raspberry Pi Foundation really bumped it up. You have a quad-core A7. So whereas this is ARMv6 instruction set, and this is ARMv6 instruction set, this is the ARMv7 instruction set, which brings it up to like modern standards of compatibility, or so-called high function. It is ARMv7 with quad core at 900 megahertz, although you can overclock it to around 1.2. It shares all the same ports, and there's no other really improvements other than the CPU itself. The GPU is the same encoders, and the memory is out on back. So this is not a POP package. This is just a BCM2836. and the memory is on the back. This one's by Elpida. So there you have it. And then with these, right, some people have noticed that these are different colors on different manufacturer boards. So usually black means it's made out of China by Invest Technologies, and white is made out of the UK by RS Components. But they've been known to swap parts because like most of the parts come from China anyway, so it's just where it's assembled. There's no quality difference between either or. Actually, in our perspective, the Chinese ones actually have less of a return rate than the UK ones. So this is the newest addition to the Raspberry Pi family. As you see, we attached the heatsink onto it because this gets very, very hot. Whereas these two, or these three, stays relatively cool. This SoC is the first 64-bit or ARMv7 instruction set chip, and the core technology is the cores are basically implementations of the ARM A53 design, and the SoC itself is about 1.4 centimeters by 1.4 centimeters, but the A53 cluster itself is very small. It's a couple millimeters at the top of this chip, whereas the GPU I/O sits in the middle of the chip. So if you don't have a heatsink on, what happens is the one cluster will, the CPU cluster will get extremely hot, whereas the rest of the die will stay relatively cool. And then you can get all kinds of funky behavior if you start running benchmarks or intensive processes that load up the CPU. It doesn't throttle correctly because the thermal sensor is located actually in the middle of the chip, not towards where the A53 cluster is or the CPU cluster is. So there's a huge disparity and it can cause you troubles. We highly recommend heat sinks for the Pi 3, whereas they were sort of optional previously. There's a heatsink for the LAN chip as well, simply because it was there and we can cool it. This is 100 megabit Ethernet, so this and this board have 100 megabit Ethernet, so they're not gigabit. And if you're driving a long cable, you're going to need a heatsink or something to cool down that chip. So you have the Wi-Fi chip here, the Wi-Fi antenna. The Wi-Fi chip is actually on the back of the board, right there. It's tiny. Same SD cards, micro SD card slot as all the other ones, and same layout. Besides, the LEDs got moved. So on the Raspberry Pi 2, the LEDs are here. Now they're here. So if you have any case, like the official Raspberry Pi Foundation case, they're still compatible, the 2 and the 3 case. It's just that the LEDs are different spots. So you won't be able to see them. You won't be able to see the LEDs on a 2 in a 3 case, and you won't be able to see LEDs on a 3 in a 2 case. But that's a trivial thing anyway. I don't think anybody is even bothered by that. Aftermarket cases usually will not have this problem. So, I mean, this is pretty run-of-the-mill. I think everybody knows about these two yet already. So where should we get started? Okay, let's get started with something out of Korea. This is the Odroid C1 Plus. It is based on Amlogic. It's called Amlogic S805. So what happened is, this is the older design. It's a Cortex-A5 design with the ARMv7 instruction set. It runs at like 1.5 gigahertz. So you got 900, 700, and 1.2 and 1 gigahertz here. This is running at 1.5. So they have a giant heatsink on it because it gets quite hot. This is a Otg port. This can be used to power the Pi, or not Pi, the Odroid. And the cool thing about this board is that it adds built-on IR, and it has battery power for our RTC clock. It doesn't have the sound, the 3.5mm jacks that the Raspberry Pis have. So the only way to output video would be by HDMI. The other cool thing is that this has an onboard gigabit chip, and the root complexes are not shared. So you get higher bandwidth through the USB ports on the individual lanes. The GPIO pins on here are slightly different in the Raspberry Pi 2s, and you have something called an I2S for basically high fidelity audio. They sell a hat, they sell a hat, which is the attachment or shield or whatever, however you want to call it, that allows you to do high quality audio. On the back, the SD card slot is moved compared to the Raspberry Pis. So you see the SD card slot is here, this one's here. And there's the eMMC connector here. eMMC is basically a faster SD bus. Yeah, that's about it for this board. So you're talking about 1.5 times the performance of these, of, let's say, this board and this board. It's going to be slightly faster than this board, the Raspberry Pi 3, but probably not by much. This is still an ARMv7 chip, so it's still 32-bit. So next we move on to the Odroid C2. This is based on the Amlogic S905. So this was 805, this is 905. It has the same IR and the same Otg Port, HDMI, etc., etc. So the improvements are they added a gig of memory to it. So you have 512, 512, 1 gig, 1 gig, 1 gig. This is now 2 gigs, and it's also based on the A53 instruction set, and it has 4 cores running at 2 gigahertz. So basically, almost double, but not quite double this. This will throttle if you load it up. Just like the Pi 3, you have heatsinks here. You sort of need active cooling for this in order to maintain high performance all the time. Same gigabit Ethernet. There's nothing really new on this board. This little jumper is to configure whether you want to use the DC barrel plug or the micro USB plug for power. One thing to note is that this is not the sort of off-the-shelf ones. You have to really buy it from them specifically, because it's a 2.5mm outside width and a 0.8mm inside width. So it's really hard to find this, which is why they allow you to power it via USB or micro USB. So one thing that does go backwards on this board is that this does not have a real-time clock. This does. So do you see the battery power port here? You don't have that on here. So if you have to do a real-time clock, you have to do it somewhere on the GPIO. This is the Odroid Xu4. This is probably the highest performance chip here. It is based on the Samsung, 5422, and it has 8 Cortex-A15 processors and 4 Cortex-A7 processors in big little configuration. What that means is that this is like basically one of the cell phone chips in your Galaxy S4 or 3, and they can distribute the load onto higher performance cores and lower performance cores. So the A15, compared to the rest of these, has it's special in that it has out of order instruction execution, which means that there's a lot of compute units on the board, and it's able to dynamically run instructions in parallel, not in parallel, but out of order if the dependencies are not overlapping. So it can actually squeeze way more performance than these boards, even though it is an older design. So the A7s on the little cores, the A7s, are still in order. So the A53s are also in order cores. When you get out of order, when you're talking about A57s, A15s, and A72s that you hear about in cell phones. This has USB 3, a power button, and basically this is a switch for determining whether you want to boot off the eMMC or the SD card here. It has a HDMI interface. Oh, that's something I also forgot to mention. This one has a HDMI 2.0 interface, so it can drive 4K, 60 frames per second. These two boards can only drive 4K at 30 frames per second, and these cannot drive 4K at all, pretty much. With some tuning, you can probably get these two to do 4K 15 frames per second, but it's a hack. It's not really supported. And this one can do 4K 30 because it's HDMI 1.4. And like the other Odroids, it has eMMC. Let's see, and one USB 2.0 port. This one also uses a different barrel plug. It's the 5.5 millimeter outside and 2.1 millimeter inside barrel plug, and it draws up to 4 amps, which is why they have this active cooling fan. This gets pretty hot. So let's move over to the Banana Pis. This Banana Pi is the Banana Pi M2. I don't have an M1 or M1 Plus, but these are higher performance variants. They're roughly equivalent to the Raspberry Pi 2s in that they're ARMv7 and 1 GB of memory on board. It's powered by a barrel plug that's more standard, the 4mm/1.7mm barrel plug, and has power management chip and HDMI 1.4. It also has camera interfaces just like the Raspberry Pi, but it's sort of different. So, and also power button. And this is the Otg port. Don't mistake this for a power port because you cannot power this board via this port. If you try to, 2 of the USBs aren't going to work, and the moment you load up the CPU, the board's going to shut down because it can't deliver enough current to the processor. The proper way to power it is via this this barrel plug. So this is based on the Allwinner chip. These boards are all based on Allwinner. Allwinner is a fabless semiconductor in China, and they deliver really low cost or cost-effective chips that are sort of inexpensive. Let's see. This has a gigabit Ethernet chip. Gigabit Ethernet, just like these. This, and this. And it also has Wi-Fi on board. Let's see what else. Yeah, and the same. It's based on an A31S Allwinner A31S, and it has Power VR graphics and 1 GHz clock rate, and let's see, OTG. Yeah, that's about it. This is a good performance board. I would say these two are roughly equivalent, although this one's slightly faster, but this one does have more interesting features, including gigabit Ethernet, whereas this really fails at that. I'm just waiting for the next Raspberry Pi where they put gigabit Ethernet on it. The downside of gigabit Ethernet is you can use power over Ethernet cables. Like if you hack a RJ45 cable, you can actually split it off to use micro USB and Ethernet over Cat 5 or 6 cable, whereas you can't do it with gigabit boards because they use all 8 conductors in the Ethernet cable. So next we're going to move on to this is the Banana Pi M3. So these two all have IR receivers, and and this one adds 8-core all-winner processor, the A83T. So this one is actually extremely fast. This will definitely beat all three of these boards, and will rival this board, or become close to this board in terms of raw performance. We're not doing like software-based support, so I'm not going over the support, but in terms of raw performance, these two are about the same. This one has a USB bridged-based SATA 2.0 port. Here is the power pin to power the device. So if you have enough current, you can power a mobile hard disk. If you have enough current in your power supply, you can power an external serial ATA. Serial ATA disk. This has HDMI 1.4, gigabit Ethernet, the same camera and display interfaces. They have a really cool 7-inch display. The camera does not work so well on these boards, but that's being improved by them. IR receivers, GPIO. This one also has Ethernet and Bluetooth by the AP6212, and it also has 2 gigs of RAM, whereas this one had 1 gig. And that's about it. There's the OTG hub port and the power port. So make sure you have a good 2 amp power supply for this. This is octa-core ARMv7 at 1.8 gigahertz. So okay, let's start with this one. This one is called the Orange Pi PC. What's really cool about this board is that this board is $15 plus shipping and handling. It's based on the all-winner H3, so it's able to decode like H265 and H264 at like 30 frames per second, which is really cool. This has an SD card slot. The beauty about these SD card slot is this is probably the best SD card slot here. It has a nice push-in, just like, and it feels really solid. Whereas the problem with the Raspberry Pi 2s were that like the spring would go bad. This one just nice push-in and solid feel all around, and feels really solid. The Pi 3 sort of followed this, but if you compare the two, the quality just doesn't feel like it's there between the two. Like there's no solid click in here. This is just basically slide in and slide out. Like you can't tell if you're in too far or too. There's no hold here. So this one has a nice, when it's in, there's a nice ridge that it hits that you get a good solid feeling out of. Okay, so this is the H3. Like I said, it's quad-core all-winner ARMv7, and it's really cheap. It has the IR receiver. It has 100 megabit Ethernet. Doesn't have gigabit, and 3 USB ports. And these USB ports have full bandwidth on every single complex. So this is also powered by the barrel plug, like this. This is not powered by the barrel plug. They have some models powered by the barrel plug, so it's really strange. Sino VoIP has not decided whether they want to use the USB or the barrel plug, so they keep switching it between boards, and it's really annoying. A camera interface supports like a 2 megapixel camera, and this has a gig of RAM. So this is about it won't quite reach this. Actually, no, they're roughly the same in performance. For this, they're roughly the same in performance, except this does not have 64-bit mode. This is a lot cheaper than this, because the running price is around $42. This is like $20–25. You can get a case, heatsink, and board for $25. So So whereas this is going to be like 50. Yeah, but there's not much to be said about here. If you're going to use this board, use ARMv7. I know I said I wouldn't cover software, but ARMv7 for orange pies and banana pies, go with ARMv7. There's some great people. There's Igor and Thomas Kaiser. They worked on ARMv7 for a long time, and it's a really great project. Then people should really contribute to that project because these boards are sort of different and better. Let's see, 1 gig. Yeah, that's about it for this board. Great board. And then we have the Orange Pi 1. This is basically a Raspberry Pi Zero competitor, even though the Raspberry Pi Zero is $5 and this is like $10 plus shipping. This has a full quad-core ARMv7 just like this chip. So it's the same chip with the same performance level and less RAM. So this is 512 megabytes of RAM, whereas this is 1 gig. It has the same micro SD slot. It has a camera slot for that 2 megapixel camera, full-size HDMI, full-size Ethernet, full-size USB. I can't iterate how much that's less a pain of the ass than this thing. You know, even if you're, unless you need to have the tiniest form factor possible, this board is heads and shoulders above this board in terms of performance and usability. So one thing to know about the Orange Pi boards is that they do not support HDMI to DVI adapters as of yet. They only support HDMI to HDMI and HDMI to VGA. So that's something to note. You still get a power switch here. And this has basically the same capability as this with an Otg port here. So if you need to expand into a 4-port USB hub, you can do it here. And it's beautiful. It's a tiny board and it does everything you want it to do. At a good price too. You can have this for like 15 to 17 bucks. The next one is, this is the Orange Pi Plus. So as we go, the difference between these two is just that this has a lot more I/O capability. It has a USB, or serial ATA, USB based serial ATA to basically plug in a hard drive with, just like the Banana Pi M3. And it has Wi-Fi on board, gigabit Ethernet that this doesn't have, these two don't have. And let's see, what else is on this board? Same power. Yeah, power, and it has an extra reset button, and yeah, that's about it. But this board is slightly more expensive than this board, specifically for the serial ATA bridge, USB serial ATA bridge. So it's not going to be native performance, it's going to be a little slower. But for these cases, it's just made for USB attached hard drives. Yeah, that's about it for this board. So gigabit Ethernet, 4 USB ports. These share the same complex, so you're going to have only one set of bandwidth through these ports, whereas these have dedicated bandwidth per port, and or for 2 of the ports, and then this one and the Otg have dedicated bandwidth. And then we're going to get into the Orange Pi Plus 2. This is a bigger version of these two. So what it comes with is the same SoC. So these 4 boards are all the same SoC. This comes with 2 gigs of RAM, and one sec, let me open my Excel. This has 16 gigabyte of eMMC built on board, so you can technically flash this device and not have to basically plug in an SD card to use it. Same with this. I forgot to mention this. This has a 8 gigabyte onboard eMMC. So it's right here. So both of these boards, this is 16 gigabyte, this is 8 gigabyte, this is 1 gig, this is 2 gigs. So they both have onboard Wi-Fi, and both have onboard serial ATA bridge via USB, and both are powered with barrel plugs. The annoying thing about these boards is that they don't have the same form factor, so it's kind of a nuisance getting cases, and the cases are all different for each board. See, like the USB is, I mean, not the SD card slot is here on this board and here on this board. So, and the boards are physically different sizes, so you can't reuse cases. Hopefully, when they come out with future boards, they will share the same form factors as these, so you can reuse the cases. But both good boards. I'm just going to get into a little bit of software support. So Raspberry Pi has the best software support out of all of these boards. Hard kernel, these are M-Logic chips. They're not very well supported in mainline Linux. So in like 2 or 3 years, you're going to be SOL if you want to run mainline Linux. If you just want to run an old Linux, these will probably work for a while. This is the Samsung Exynos. They've been supporting it pretty well in mainline Linux. These are, the A31S already has mainline support. The T83 is going to have mainline support in the next release of Linux, which is 4.6. Mind you, this is not, mainline support does not include all of the features on the board. It just supports booting up the SoC. You might have to do a little work, or the distribution packagers will have to do a little work to support each of these boards, or all of the features on each of these boards. And then the H3 is already mainlined in, I think, Linux 4.4. So, and let's see. So both of these are based on PowerVR. These are based on Mali. So these are ARM-based GPUs. And the ARM GPUs over the long run will probably have mainline kernel support. The PowerVR, well, it depends on if Imation keeps it up. Their open source work. Last I heard, they were sort of doing it and sort of not doing it at the same time. So it's really strange. The VC4 on the Raspberry Pi, the GPU, are basically, the GPU is becoming open source and getting mainlined into the different kernel versions. It still doesn't quite work well, but you know, it's improving. And these are all Mali based graphics. So just like the Orange Pi boards, they're probably going to have mainline graphical support, if not soon, eventually. What else? Yeah, so there you have it. That covers basically most of these boards, and I hope you found this review informative. I will have another performance review based, or software / performance review based on these boards in the coming weeks. I've been pretty busy. I got an Embedded Linux conference to go to next week, and you know, get out there and enjoy these boards and learn about low-level embedded computing, because these things are going to take over your desktops in the future. You know, you're going to have one of these boards like sitting in a case in your pocket, and you're going to take it to wherever it is you are, plug it in, and there you have a full-blown computer. Hope you enjoyed this video. Subscribe to get more updates on these boards as I get time to review them.